Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 higher tier. This is the specimen paper, and question number 5 is on the topic of energy, and it looks like it is to do with work done. So, a student investigated the efficiency of a motor using the equipment in figure 4. So, as you can see, there's a motor which is going to spin the pulley. As it winds up, it is going to lift this weight of 2.5 Newton to a height of 2 meters. It looks like he used the motor to lift a weight of 2.5 Newton to a height of 2 meters. He measured the speed at which the weight was lifted and calculated the efficiency of the energy transfer. He repeated the experiment to gain 2 sets of data. Question 5.1. Give one variable that the student controlled in his investigation. So if you're trying to find out the efficiency while lifting 2.5 newtons through a height of 2 meters and you're repeating it twice, you wouldn't want to change the height that you're lifting the weight, and you wouldn't even want to change the weight, the amount of weight as well. So they're only asking for one of the variables, so you could say any of this, the weight lifted or the height lifted. Give 2 reasons for taking repeat readings in an investigation. Why would you want to take repeat readings? Now, by taking repeat readings, you could calculate a mean. Now, if during the course, let's say you take 3 readings, and if one of the reading is incorrect, or if the first reading is incorrect, and the next 2 are very similar, it helps you to spot anomalies. So if you just do it once, and if it's a wrong reading, then you wouldn't know whether it was correct or not. But if you repeat it, what you're looking for is similar results or the same results. So any of this will get you, any 2 of this will actually get you both the marks. To calculate a mean, to spot anomalies, and the third one is to reduce the effect of random errors. The first 2 bullet points I think are the best for this answer. To calculate a mean and to spot anomalies. Figure 5 shows a graph of the students' results. The efficiency, as you can see, looks like it's increasing as the speed increases, but it's not increasing straight, but it's increasing, and then the rate at which it's increasing is going down. Now, if that line was to continue, it'll probably go flat. Oops, I didn't want it to be a straight line like that. Probably going to go flat after some time. So give 2 conclusions that could be made from the data in figure 5. So the conclusion that you can make is that as the speed increases, the speed is going from 0.5, it's actually starting, the first is starting around 0.7, right? 0.07, right? It's that box. From about 0.07 meters per second, the speed is increasing, or the efficiency is increasing as the speed increases. That's your first mark. And the second mark is, you could say, but the rate at which the efficiency increases reduces with higher speeds. Or you could say it appears that it's going to flatline or be constant after a certain amount of speed. So here's a possible answer. As speed increases, the efficiency increases. That gives you a mark. And the second mark, but graph tends towards a constant value or appears to reach a limit, is your second mark. Question 5.4. Give the main way that the motor is likely to waste energy. Almost all electrical equipments waste energy in the form of heat. Even if it is a hairdryer, some heat is lost to the surroundings. So heating the surroundings is your answer. 5.5. When the total power output in the motor was 5 watt, the motor could not lift the 2.5 Newton weight. State the efficiency of the motor. Now, when the total input is 5 watt and if it can't lift the motor, that means all the energy, that is this 5 watt of power, is actually going to waste because it's not lifting the weight at all. So the efficiency is basically 0. Question number 6 is on the topic of electricity, mainly to do with static electricity. Figure 6 shows a Van der Graaf generator that is used to investigate static electricity. Before it is switched on, the metal dome has no net charge. After it is switched on, the metal dome, which is basically this bit on the top, becomes positively charged. Now, the question is, why would that become positively charged? Now, remember, atoms are neutral, but because it's a metal, it has electrons which can be removed. So this black thing is actually a belt that spins around, and it's caused to spin around by a motor, and this is actually the speed controller here. As the belt spins, it removes electrons from the dome, and this bottom part of the belt actually becomes negatively charged. Question: explain how an uncharged object may become positively charged. For an uncharged object to become positively charged, you will have to remove the negatively charged electrons from that object. So the answer, the negatively charged electrons are transferred from the neutral object, which is basically the metal dome. You could complete it by saying to the belt, but here they are looking for the 3 marks, they're looking for, have you mentioned the negatively charged, and have you mentioned that the it's the electrons that are transferred from the object, not to the neutral object. Next part, figure 7 shows a plan view of the positively charged metal dome on a Van der Graaf generator. Draw the electric field pattern around the metal dome when it is isolated from its surrounding. Use arrows to show the direction of the electric field. So to draw the electric field pattern, you will get a mark, and if you get the arrows correct, you will get the second mark. So that's your positively charged metal dome as a sphere. What would the field look like? You need to draw straight lines, and there's a minimum of 4 that you need to draw. So let me draw these 4 lines. Right. Now the question is it going to be pointing towards the positive charge or away? Now, the direction of our electric field is from positive to negative. So because this is positive, it should all be pointing away. Now the arrowheads need to be on the line, preferably, rather than at the end. This is the minimum number of lines and the arrows pointing, but you could draw another 4 just to make it clear. There you go. On a side note, if it was a negative charge, then the field lines would actually look like this. It will be pointing towards the negative charge. Next part, Another positively charged object is placed in the electric field. Look at figure 8. So you've got figure 8 and there's 4 points marked in there, P, Q, R and S. In which position would the object experience the greatest force? Remember, what they're placing is another positive charge, so all of these are positive charges. Now positive charge and a positive charge would actually repel. So let me just make sure, is it a, yes, it is another positively charged object. So in which point will it actually experience the greatest repulsive force? That would be where it's actually closest, which is going to be Q, and the furthest I think is P over here. So the answer is Q. That brings us to the end of the video, and I will see you in the next video.